We studied in the last class what is acceleration. So can you tell me what is the acceleration formula we have been made? Acceleration is equals to what? Final
Uh,
velocity minus
Final velocity plus initial velocity.
Mari plus
And
minus final velocity minus initial velocity divided by time taken. So this final velocity minus initial velocity only we used to call as what? Everybody, all of you, change in velocity. Yes or no? So change in velocity divided by time taken for the change of velocity. So that is what is acceleration. And can you tell me what is the SI unit of acceleration? Everybody, SI unit of
meter per
acceleration
second
is
square.
what? Meter per second square. Reading is also very, very important. Meter per second square. And in last class, I have taught you three things. When acceleration is zero, when acceleration is positive, when acceleration is negative. Do you all remember every point? Please respond. Acceleration
Yes,
is
sir.
zero, acceleration is positive, acceleration is negative. Yes sir, no, Mr. Gokul Raj, Kishore. And then we studied 2 points. When we can say when body is traveling, moves without acceleration or zero acceleration. Without or zero acceleration. Now tell me, without or zero acceleration. So that body is said to be in what? Uniform motion or non-uniform motion? Yes, please. Without acceleration or
Uniform motion.
zero acceleration, yes, zero acceleration, then the body is said to be in what, guys? Everybody. The body is
Uniform
said to be unaccelerated motion, unaccelerated motion, or also we can call it as what? Everybody. Uniform
motion.
motion. Uniform motion. Okay. Next, if when a body moves with a certain acceleration is there, either it is a positive or negative or doesn't matter. If the body is having certain acceleration, then the motion of the body is said to be what? All of you, accelerated motion, or we can say what? Non-uniform. Everybody, non-uniform motion. Last, you have written these two statements, yesterday's class. Verify it. You have written or not? Mr. Lingesh?
Yes, sir.
Yes, everybody. So keep it in mind, without acceleration or zero acceleration, then the body is said to be in uniform motion or unaccelerated motion. If certain velocity, certain acceleration, either it may be a positive or negative acceleration, doesn't matter. Then the body is said to be accelerated motion and it is non-uniform motion, or we can say non-uniform motion. Ellame clear? Sailesh, Gokul, everybody.
Sir.
What is the formula for acceleration, Sailesh? Repeat this formula. What is this formula? Acceleration is equals to final velocity minus initial velocity divided by what, guys? Everybody, time taken. Clear? At least formula you should know. Mr. Sailesh, can you hear me? And what is the units of acceleration? Units of acceleration. Meter per second square. Square meter illa. Meter per second square. Meter per second square. Read it 2-3 times. Meter per second square. Sariya? You say 5 times, it will come. Units of acceleration, meter per second square. Units of speed and velocity. What is the units of speed and velocity, guys? Both are same. Everybody? Agalya? What is the units of speed and
Meter per
velocity?
second.
Meter per second alone. This is, yeah, this is meter per second. And this is meter per second square. Purima? Shivani, Sangamitrai? That is what. So if anybody will ask, you should be at least able to say units. Speed and velocity has meter per second. Acceleration, meter per second square. Clear? Next, in our today's class, we are going to study the next concept is uniform types of acceleration. Please, all of you keep ready. Types of acceleration. So let's start, everyone. Are you all ready? Okay. So we are having acceleration can be mainly two types. So one is again the same thing which we all people knows. uniform acceleration. And the second one is what, guys? Opposite to that.
Non-uniform.
Yeah, non-uniform acceleration. Are you all clear? So let us discuss one by
Yes, sir.
one. So please keep reading. First one, uniform acceleration. Let us write the definition so that you will understand very clearly. Take the notes properly, Mr. Sailesh, Mr. Gokul Raj, everybody, Kishore. I'll check the notebooks. Right. Definition. When the velocity of a body, whenever I'm speaking velocity, means body is moving straight line or some unknown path. Anybody? Straight line. Keep it in mind. When the velocity of a body, whenever I say velocity, immediately body is moving what? Body is moving in a straight line. Keep it in mind. When the velocity of a body moving along a straight line, moving along a straight line changes equally in equal interval of time. In equal interval of time. I'll give the examples. Equal intervals of time. Then the acceleration of the body. Then the acceleration of the body is known as, what is that, guys? Uniform or non-uniform motion?
Uniform motion.
Uniform acceleration, not motion, Mari. Sariya? Uniform acceleration. Clear? Yes, please. All of you respond. So, in this case, velocity changing at uniform rate or non-uniform rate? Velocity changing
Uniform.
at uniform rate. That is what. Okay. So, in this case, Mr. Lingesh understood Lingesh definition?
Yes, sir. Understood.
Yeah. The velocity of the body changes at uniform rate. Changes at a uniform rate. I will give you the example so that you will be 100% very clear. Okay. So let us discuss. Shall we discuss it now? So what is the definition? Everybody, what you understand, you tell me. Yes, please. What you understand uniform acceleration? Acceleration or accelerated motion? Same thing. Uniform accelerated motion. Suppose I say Mr. Kishore is in uniform accelerated motion. Can you tell me what do you mean by that? Mr. Kishore is in uniform accelerated motion. Uniform accelerated motion. So means in the sense of what? His velocity changing equally in equal interval of time. Yes or no? His velocity changes equally in equal interval of time. Then I can say Mr. Kishore is said to be in what? Uniformly accelerated motion. Understand, everybody? So let us verify it. Sir, what does it mean? Let me take example. For example, now let me take Mr. Kishore, Mr. Mari, and Mr. Lingesh and Mr. Sanjay. All are there traveling in a trip. So Mr. Sanjay is driving a car. Let me take. So now his initial velocity, I'm not saying he started from rest. Can I take started from rest, everybody? Starting from rest in the sense of, what is the initial velocity? Anybody can tell me?
0.
Yes, please. Initial velocity u is equals to how much? Starting from rest. 0 meter per second. Be very careful. Starting from rest, initial velocity is 0. Came to rest, final velocity is what? Came to rest. Keep it in mind. Came to rest after applying the brakes. Final velocity is 0. Now, starting from rest, what we used to call, Shivani? Starting from rest, initial velocity is what?
0.
Initial velocity is 0. Clear? V means final velocity and U means initial velocity. So came to rest means how you can bring the body to rest? By applying brakes or by applying accelerator? Anybody?
Break.
By applying, yes, please.
Break.
By applying brakes. Do you all clear? Please respond, all of you. Now, let us take, as I told, Mr. Sanjay, Mr. Mari, Mr. Kishore, and Mr. Lingesh is in a trip, and they are started from the rest. So their initial velocity is what, guys? 0. Clear? After 5 seconds, Mr. Sanjay bought the car into a velocity of, okay. So let me take that velocity. Can I take it as a V1, or else can I take it as a, let me take this is V1. Is it okay, guys? U is equals to V1. Any doubt, any problem for anybody? U is equals to V1. So here I will take it as a V2. So V2 is equals to 10 meter per second. What is the velocity after 5 seconds? Everybody? What is the velocity after 5 seconds? 10 meter per second. Can you find the acceleration from here? Let me take acceleration. A1 is equals to final velocity. Tell me what is the final velocity? V2 minus initial velocity V1 divided
V1.
by time taken, time t, which is equals to how much, guys? 10 minus 0 divided by 5, which is equals to what is the acceleration?
2
10
meter
by
per second
5,
square.
which is equals to 2 meter per second square. Ellame clear? Sanjay, Pranav, Lingesh?
Yes, sir.
Yes. Next.
Yes.
Next 5 seconds. Next 5 seconds. Again, see equal interval of time. Mr. Sanjay bought the car into a velocity of V3 20 meter per second. Now tell me from here to here what is the acceleration? A2. A2 is equals to, solunga fastly, formula. V3 minus V2 divided by time, which is equals to V3 is 20 minus V2 is 10 divided by time is 5. So which is equals to what, guys? 10 by 5. Again, what is the acceleration? All of you. Pranav?
2 meter per second.
2 meter per second square. Understand, Agalya? Agalya? Next, again,
Yes, sir.
next 5 seconds. Again, next 5 seconds. He bought into a velocity of V4 30 meter per second. Now tell me what is the acceleration? Formula, everybody. Acceleration A3 is equals to, everybody tell me. V4 minus V3 divided by T. So V4 is what? 30
30.
minus V3 is what? 20 divided by 5. So which is equals how much? 10 divided by 5. Again, what is the acceleration?
2 meter
2
per
meter per
second.
second
2 meter
square.
per second square. Understand, Shivani? So then I can say, Mr. Sanjay is in what acceleration? Everybody, Sanjay car is traveling with what acceleration? Uniform acceleration. Have you noticed it? Because velocity changes uniformly in uniform time or equally in equal interval of time. 0 to 10, 10 meter per second. 10 to 20, 10 meter per second. 20 to 30, 10 meter per second. So I can say Mr. Sanjay is traveling said to be in uniformly accelerated motion because acceleration has a constant value. What is the constant value in Sanjay case? Acceleration is constant. What is that value? 2 meter per second square, 2 meter per second square, 2 meter per second square.
All the acceleration.
Yes,
Same.
so, acceleration has a constant. Acceleration has a constant value. So then what motion? A body is said to be in what motion? Everybody, please respond. It is
Uniform acceleration.
uniform acceleration. Are you all clear? Everybody, any doubt? Mr. Sailesh, nothing written, simply sitting. Are you sleeping, Sailesh? Are you listening?
Listening, sir.
Listening. Are you writing the notes?
Yes, sir.
Really? Good.
Really,
Yeah,
sir.
if you're writing, very good. Do you understand what is the acceleration formula, Sailesh? Can you tell me? What is the acceleration formula? Just final velocity minus initial velocity divided by what? T means what, Sailesh? T means what? T means what, Ra?
Time, sir.
Time. That he should say, Mariv. What I can do? I'm trying to make him to active. T means time. You don't know, Mr. Sailesh? V means final velocity, U means initial velocity, T means time period. That's all. Okay, do it. Completed everybody? Accelerated motion. Alfin, Darshan, no response at all. Do it seriously.
Completed, sir.
Yeah, make it fast. Okay, next. Finish it, Sanjay. Everybody complete it. So that is what. So can we make examples for uniformly acceleration or uniformly accelerated motion? Whatever it is. So let us write three things so that you'll understand it. So complete this fastly. Uniformly accelerated motion. Kishore, Purima, Kishore, neatly understood?
Yes,
At
sir.
least in chat you can respond. So silence is not your a good thing, good behavior. You should say yes or no, what you know at least. Sangamitra, you also. Next, keep heading examples for uniform acceleration. Examples for uniform acceleration or uniformly accelerated motion. Same, both are same, Lingesh. Uniform acceleration or uniformly accelerated motion, both are same. Clear? Understand? General language will say uniform acceleration, but the body is said to be uniformly accelerated motion. That's all. Nothing is there. Clear? Everybody understood?
Yes,
Again?
sir.
Yeah. So
Yes.
any example for uniformly accelerated motion in our daily life? We all people studied from the lower classes. Yes. Suppose
The train.
no train will go with the uniform accelerated motion, Mari. Now look into the board, Mari. Very clear. Now, all of you observe very carefully. Any kind of body under free fall, motion of a freely falling body only because of one force. One force is down, pulling. What is that force? Can you tell me?
Gravitational.
Yeah, gravitational force of Earth. Gravitational force of Earth. Keep it in mind. If any body is falling towards to the Earth only because of gravitational force, then that body is said to be in what? Uniformly accelerated motion. So let me take now, Mr. Silas has been taken into a terrace where he is having a 5-story building. Understand, Mr. Silas? So 5-story building including the ground floor, and Mr. Silas went to the top of the terrace at the edge and he dropped one stone. So that stone is falling towards to the ground. A body under free fall. We can say that body is called as what? Body under free fall. Freely it is falling. That is an example of uniform acceleration or uniformly accelerated motion. Sir, why, sir? Means continuously the gravitational force of the earth. How much active, you know, guys? If any body is falling towards to the earth, all of you observe, the acceleration is continuously acting same. G is equals to 9.8 meter per second square. G is equals to 9.8 meter per second square. G is equals to 9.8 meter per second square. Actually, don't think that A is equals to G. A means acceleration, G means gravitational, and acceleration due to gravity. Sariya, Sanjay? So, understand, Lingesh? So I can say, what is the first example for uniform acceleration or uniformly accelerated motion? Everybody, motion of a
Freely falling body.
motion of a freely falling body under the what force? Body.
Gravitational.
Yeah, under the effect of gravity. Any doubt? Anybody can let me know. Clear? Yes, Shivani, we can make, but clock also we can make it. Nothing is there, but same thing we can. Okay, same way. Yeah, Shivani is saying the clock, but clock is like in the sense of course, we can say clock is also in uniformly accelerated motion. Continuously, it will be in the same distance, same speed. It will be carrying on the same interval of time. Yes, Shivani, you can say. Next, motion of a body thrown vertically upward. See, now it is freely falling, freely falling. Now down, Mr. Gokul Raj is there. Is there, Mr. Gokul Raj? Can you hear me? Mr. Gokul is present. Mr. Gokul has been thrown one stone. It will go up, it will go up, it will go up, it will go up. Okay, like that. So when it is going up continuously, see, when coming down, velocity keep on increases. Velocity increases. When going up, velocity decreases or increases. Anybody can tell me?
Decreases.
Velocity decreases. That is what you have to remember. When it will reaches to the maximum height, velocity become what, Mari? Velocity
Increases.
becomes zero. Okay, velocity becomes zero when it will reaches to the maximum height. Is it okay, guys? Everybody, please respond.
Yes, sir.
Yeah. When the body will reaches to the maximum height, velocity decreases. Zero it will become. So when body is thrown up, this is also what motion? Uniformly accelerated motion. So take it. Motion of a body thrown vertically upwards. Clear, Kishore, Pranav? Thrown
Yes, sir.
vertically upwards. Ella pair clear? Any doubt anybody can ask. Motion of a body thrown vertically upwards. That is the second example. Okay, Shivani, Sangamitrai? No response.
Yes, sir.
Next, third example, you all people know very well. Observe very carefully. Third example. Have you all observed inclined plane, inclined surface? Any one of you? Inclined surfaces. Like for example, this is the inclined surface. Yes, Mr. Mari, Mr. Lingesh.
Yes, sir.
Yeah.
Yes,
So
sir.
basically, this is what we can say inclined surface.
Like a ramp.
Yeah, like a ramp. Very good. Now I put the one ball here. Then what will happen? You tell me. That ball will started moving, rolling,
Rolling.
rolling. It will be continuously rolling. So then, if any body is moving in an inclined surface, then that body is said to be in what? Everybody. Yes, please. All of you. Motion of a ball rolling down on a smooth surface, smooth inclined plane. Which acceleration? Everybody. Uniformly accelerated motion. So that is what 3 examples. Hope you are all clear. Any doubt anybody can ask me. Understand, Mr. Gokul Raj, Sanjay? Please respond. Okay. So these are the 3 examples you can make. As Shivani said, you can make clock also. Okay, no issues, because clock is also equal distance, equal interval of time. So velocity is same and velocity is increasing in uniformly. So that it's okay, we can say that also. Do it fast. But the problem is velocity, the value is always remains constant at every point. Only direction is keep on changes. So direction changes means velocity changes or not? Everybody. All of you.
Yes, sir.
Yeah. So can you tell me in wall clock? Suppose see, I will say Mr. Sanjay is traveling, for example, velocity of Sanjay is 20 meter per second towards east. Mr. Same Sanjay velocity is 20 meter per second towards to north. Is it both are same or different? Both are same or different?
Different, sir.
Different. Understanding? This is different velocity, this is different velocity. Of course, their magnitude, both the cases, magnitude is constant, but who is not constant?
Direction.
Yeah, magnitude is same, but the thing is direction is not same. So these both velocities are not same. Is it okay, everybody? Kishore, Pranav? That is what you have to be very careful. Understood, Amma? Sangamitrai? Yes, uniform acceleration.
Yes, sir.
Lingesh is saying, sir, moon orbiting the earth. Uniform acceleration. Yes, it is continuously with the same speed, same velocity, and continuously velocities keep on changes in a uniform rate. So we can say that. That's fine. Okay. So these are the familiar examples you can take for uniform acceleration. I hope you all understand. Then we are going to study opposite to the uniform acceleration motion. We can say what?
Non-uniform.
Non-uniform or also we can
Accelerate.
call with another name. Everybody. Variable.
Non-uniformly accelerated
Yeah.
motion.
No, non-uniform or yesterday you told Mari, variable
Variable.
yeah, variable acceleration. Shall we start now? Everybody, are you ready? Explain the three. Third one, nothing Kishore. If any ball or any kind of object is falling in an inclined surface, then its velocities keep on changes at a uniform rate so that the body is said to be in uniform acceleration. Any body is falling in an inclined surface, rolling on inclined surface, that body is in uniform acceleration. That's all. Okay, Kishore.
Okay, sir.
Yeah. Mr. Gokul, can you hear me, Gokul? Now, non-uniform or variable acceleration, please respond. Now you are traveling in a busy road, like you are traveling in a Chennai, you are traveling in even Pudukottai, you tell me, or you are traveling in a car, you said to be in uniform acceleration or non-uniform acceleration? Anybody of you?
Non-uniform.
Non-uniform, sir.
Non-uniform. So it is impossible to go with uniform velocity. Yes or no, guys? Uniform acceleration.
Yes, sir.
Because speed breakers are there, because we have vehicles are there, we have a traffic, we have somewhere more big roads are there, somewhere narrow roads are there, somewhere big pits are there in the road, and some suddenly people will come. So is it possible to go with the same uniform acceleration? If you go with uniform
sir.
acceleration, you will meet with an accident. Yes or no, guys? That's the reason. Okay. So always when we're traveling in a busy road, is an example of what? Non-uniform acceleration. Yes, or variable acceleration. Write the definition. When the velocity of the body changes, when the velocity of the body changes, unequally in equal interval of time. Unequally in equal intervals of time. Intervals of time are equally in what? Equally in unequal interval of time, whatever it is, in a interval of time, then the acceleration of the body, then the acceleration of the body is known as what, guys? Is known as non-uniform or uniform?
Non-uniform.
Non-uniform acceleration, or also what we used to call
Variable acceleration.
variable acceleration. So in this case, velocity is constant or not constant?
Not constant.
Not constant. In this case, rate of change of velocity. Rate of change of velocity means what we used to call term. Yesterday I told rate of change of velocity is known as rate of change of velocity. Whenever you will get a rate in the sense of what? Time, with respect to time. So rate of change of velocity is known as what?
Acceleration.
That is what I am asking. Rate of change of velocity is known as what? Is known as?
Acceleration.
Acceleration.
Please remember, rate means with respect to time. Change in velocity with respect to time is known as what? Change in velocity with respect to time is known as?
Acceleration.
Keep it in mind. Rate of change of velocity indicates that always what? Acceleration.
Acceleration.
Okay, everybody clear it. So I will say now again. Let me take this time girls trip. Agalya, Shivani, and Alpin and Sangamitrai. உங்களுக்கு 4 girls இருக்கா? 4 girls are traveling in a trip. They are traveling in a busy road now. Miss Agalya is driving a car, and Alpin and Sangamitrai and Shivani is sitting. So they started from the rest. Started from rest means in a sense of what is their initial velocity? Everybody. Let me take
Zero.
initial velocity u is equals to v1 is equals to 0 meter per second. Ellame clear? Now, after 5 seconds, Miss Agalya brought the car into a velocity of v1 is equals to 10 meter per second. Clear? And after next 5 seconds, Agalya brought the car into a velocity of, let me take v2 is equals to 50 meter per second. Next 5 seconds, Agalya brought the car into, again she has to put, she cannot go with the increasing only continuously, she has to put brakes also. Let's come back again. She brought the car into the 30 meter per second. Like that she is traveling. Do you all understand, everybody? Initially starting from rest, within 5 seconds 10 meter per second, next 5 seconds 50 meter per second, next 5 seconds again reduced. So decreased means negative acceleration or positive acceleration? Anybody? Decreased.
Negative.
Negative acceleration.
Clear, everybody? Negative acceleration also called as, yesterday I told Lingesh, negative acceleration is known as retardation, or we can say deacceleration. Now
Acceleration.
find in this case, first case acceleration a1 is equals to v1 minus, sorry, this is v2, this is v2, this is v3, and this is v4. Now tell me, v2 minus v1 divided by time, which is equals to 10 minus 0 divided by 5,
Meter per
which is
second
equals
square.
to 10 by 5, which is equals to 2 meter per second square.
Second square.
A2 is equals to v3 minus v2 divided by time, which is equals to how much? 50 minus 10 divided by 5,
8 meter per second square.
40 by 5, which is equals to 8 meter per second square. Ellame purima or not? So
Yes,
next,
sir.
Yes, sir.
A3 is equals to V4 minus V3. Always final minus initial only. Decreased or increased doesn't matter. V4 evalama? V4 30 minus V3 is 50 divided by 5. So 30 minus 50, how much, guys?
Minus 20.
Minus 20. Minus 20 divided by 5. 5 ones are 5 fours are.
Minus 4.
So minus
Meter per
4
second
meter per second square. Minus indicating what? Accelerating, decreasing or increasing?
Decreases.
Decreasing. Decreasing acceleration. Ellame clear? Sanjay, Lingesh? Yes?
Yes, sir.
Yeah. So have you noticed it? Here acceleration is constant or not constant? Changes.
Not constant.
Yes. Acceleration does not remains constant. Acceleration does not remains constant with understanding. It changes with the time. Is it okay, Mari? Changes with the time. Understand, Shivani? Agalya? It will changes with the time. That is what you have to remember. Any doubt, Erika? Please ask. Are you understand? Clear, Sanjay? Okay. Please respond. So in our daily life, we will use which one? Uniformly or non-uniformly?
Non-uniform.
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 Acceleration. Clear? So examples. Examples. The motion of a moving car on a busy road. The motion of a moving car on a busy road. Any doubt, anybody can ask. Next, first example. Second example. The motion of a bus entering or leaving the bus stop. The motion of a bus entering or leaving the bus stop. Is it okay, guys? Example, everybody. Purima, Puriyada.
Yes, sir.
Yeah. So this is what about uniform and non-uniform acceleration. Hope you all understand. Now, I will say you certain points. You till here you complete it. Meeting is going to end and join back. Then I will say certain points which is very, very important for our numerical solving and our real life applications also. and then we'll wind up today's class. Then tomorrow fully we'll discuss numericals and what is the graphical representation of motion directly. Is it okay, everybody? Are you all understood or not?
Yes, sir.
Mr. Gokul Raj?
Yes, sir.
Yeah, complete this till here. Sanjay, complete it. I'm giving time now. So we have 1 minute time, finish it everybody, then we'll proceed from here. So run example for non-uniform acceleration and 3 examples for uniform acceleration. Totally I have given. Now finish it completely.